Hello everyone, so today I will be going through Specialist Maths Exam 1 2023. Now I'm a bit rusty at Specialist Maths, so if I do make any mistakes, just let me know down in the comment and I'll be sure to address it. Anyway, let's get started. So consider the function f with this rule over here and show that the rule of function can be written as this. So I think they're asking us to do long division over here, so let's do that real quick. So x squared plus x minus 6 and x squared minus x. So become 2x minus 6, so plus 2, 2x minus 2, and this will give us minus 4. So that would mean that we get x plus 2 minus 4 on x minus 1 as our f of x. So there you go, that's how you do this. Sketch the graph below labeling any asymptotes with the equations. Okay, so one of the asymptote is going to be this, and the other one is going to be vertical asymptote, which is x equal to 1. So what I'm going to do is I'm going to draw the asymptote and see how good I am with drawing them. So, okay, there you go. So, okay, that's roughly, not really, but that's roughly y equals to x plus 2. And this is x equals to 1. Now keep in mind, if you drew something like this in the exam, then yeah, you're gonna get penalized because it's like a hunch. But anyway, let us start by finding the axial intercepts now, since we have the asymptotes already. So let's start off by finding the y-intercepts f of 0. We are going to get 2 and then plus 4, so that's equal to 6. So y-intercept is going to be 0 and 6, so it's going to be here. Now let us find the x-intercept. So f of x equals to 0, so that means x squared plus x, and then what was it, minus 6 over x minus 1 equals to 0. So x squared plus x minus 6 equals to 0. So x plus 3 and x minus 2 equals to 0. So meaning of x-intercepts are going to be x equals to minus 3 and x equals to 2. So minus 3 and 2. So a graph is going to look something like this and something like that. Okay, let us quickly just label our intercepts. 0, 6, minus 3 and 0, and this will be 2 and 0. Okay, so that's how you do this question. Now moving on to question number 2. So we have this complex number question over here. So consider the complex number z equals to this, where b is positive real number. Find b given that argument of z is going to be minus pi on 2. So argument of b minus I whole cubed is going to be minus pi on 2, which means that argument of b minus I is going to be minus pi on 6. So now we can see this as a trigonometric problem. So let me just plot the graph. So this is real number and this is going to be imaginary part. So negative I and b, so that's somewhere going to be here, and this is going to be minus pi on 6, this angle, and b and negative 1. So now we can just use tangent to find this. So tangent inverse of minus 1 on b equals to minus pi on 6. So negative 1 on b equals to minus pi on 6. Oh, sorry, not minus pi on 6. That would be tangent of minus pi on 6. So that would be negative 1 on b, which is equals to negative 1 on root 3, because tangent is going to be negative in fourth quadrant. So yeah, and now that means that our b is going to be root 3. So I think that's going to be the answer, and it does matches the criteria that b is going to be a positive real number. Okay. A particle move along a straight line. Okay. When a particle is x meters from the origin, its velocity is given by this. Okay, cool. We have to find the acceleration of this particle when x equals to 2. So, let me just do the long division of this real quick. So 2x minus 1, 3x plus 2, so 3.5, I think it would be. Yep, so that would be 3x minus 3 on 2. Just take that away, so that will give us 3 on 2 plus 2, which is going to be 7 on 2. So 7 on 2. So the expanded form of this would be 7 on 2, 2x minus 1 plus 3 on 2. Okay, and now we can say that our acceleration is going to be v times dv dx. So dv dx is going to be minus 7. Okay, let me just write this as 7 on 2 times 2x minus 1 to the power of 1. Okay, so that will be minus 7 on 2 times 2x minus 1 to the power of negative 2 times 2. And then this 3 on 2 would just be disregarded, so no problem with that. And this will give us an answer of minus 7 on 2 minus 1 whole squared. Now timesing it by the velocity, which would be, I think there has to be an easier way of doing this, but I'm just going to proceed since I've already chosen this way to do it. So 2x minus 1 times minus 7 on 2x minus 1 whole squared. Okay, so that is going to be our acceleration, and what I'm now going to do, I'm just going to substitute when x equals to 2, which would be 6 plus 2, 8 on 4 minus 1, 3 times by minus 7 on 4 minus 1, 3, 9. Okay, so that would be minus 56 on 27 meters per second squared. Okay, this looks a bit suspicious. So if this is wrong, just let me know down in the comments. Anyway, let's move on. So find the value of velocity of the particle that particle approaches x become very large. So, okay. So when x becomes really large, I'm looking at this equation over here. So when x becomes really large, this entire chunk will just approach 0. So final answer is just going to be 3 on 2 meters per second. Okay, moving on. So question number 4. So we have to use implicit differentiation. So consider the relation this and use implicit differentiation to find gradient at this point. Give your answer in the form of this. Okay. So what I'm going to do, I'm just going to first differentiate the arc sine already. So arc sine y squared. And if I differentiate this, I'll get 2y on 1 minus y to the power of 4, I believe. So now we can just use that. So I'm going to differentiate. So applying product rule, I'm going to say I'm differentiating x first. So we'll just get arc sine squared y squared plus x times differentiating arc sine y squared now. So this will be the whole chunk over here. So 1 minus y to the power of 4. And then times it by dy dx, which is going to be 0. And now I'm just going to substitute in the coordinates in case if I make any algebraic mistake later on while I make dy dx the subject. So that, and we will get arc sine of half plus 6 times 2 times y, which is going to be 2 on root 2 divided by 1 minus y to the power of 4. So 1 on square root of 2 to the power of 4 will be 1 on 4, so that would be 3 root 3 on root whole square root of root 3 on 4. Okay, there we go. Dy dx equals to 0, so that would give us pi on 6 plus okay, so 2 root 2 times 2 on root 3, that will give us 4 on root 6. So that will give us 24 on root 6 dy dx equals to 0. So we will get 24 on root 6 dy dx equals to minus pi on 6. So that means dy dx is going to be minus pi on 6 times square root of 6 on 24, which will get minus pi times square root of 6 on 24 times 5 is 120, so 144. Okay, so I'm just going to state that a equals to 6 and b equals to 144. Not necessary that you state this, but I still do it just to be very safe. Okay. Evaluate this following integral over here. So, okay, this looks like an integration by parts question. Okay, so let u equals to log base e of x and dv equals to x squared. Okay, so integral of u dv equals to uv minus integral of du dx times v. Okay, so u times v is, okay, so dv is going to be x squared, so v is going to be x cubed on 3, so which would mean that log base e of x, so that would just become x cubed log base e of x on 3, and of course we shouldn't forget our terminals 1 and 2, minus integral of, so du dx, that would give us 1 on x, so 1 on x, 1, 2, times v again, so that would be x cubed on 3 dx. Okay, so ultimately that would become x cubed log base e of x divided by 3, 1 and 2, minus integral of 1 and 2, and then x squared on 3 dx. So now I'm just going to finally just integrate, so we'll get let me just integrate this, so this will just become x cubed on 9, so x cubed on 9, 1 and 2. Now substituting the points in, so 8 log base e of x, log base e of 2, I'm sorry, and take away log base e of 1 is just going to be 0, so that will just make the whole fraction 0, so not to worry about that. And we'll get 8 on 9 minus 1 on 9, so this will just become 7 on 9, and that I believe should be our answer. Moving on to question number 6. Okay, so we are given that this is a big one. Josie travels from home to work in city. She drives a car to a train station, waits, then rides on a train to the city. Okay, the time xc minutes taken to drive, okay, is normally distributed with a mean of 20 minutes and standard deviation of 6 minutes. The waiting time xw minutes for the train is normally distributed with a mean of 8 minutes and standard deviation of root 3 minutes. Okay. The time xt minutes taken to ride on a train to the city also is normally distributed with a mean of 12 minutes and standard deviation of 5 minutes. The 3 times are independent of each other. Right. Okay. So we have to find the mean and standard deviation of the total time in minutes it takes for Josie to travel from home to city. Okay, so she drives a car to the train station. So driving a car to the train station will have, so exc is going to be 20 minutes. E of x, and then she waits. So xw will have a mean of, where is it? 8 minutes, okay. And E of xt, so taken to ride on train to the city is also distributed with mean of 12. So 12 minutes over here. So a total time, what should I call that? So let total time be denoted by t. Okay, so E of t is just going to be E of xc plus xw plus xt, which would be e of xc plus e of xw plus e of xt, which would just be that 20 plus 8 plus 12, so that will be 40 minutes. So e of t will thereby be 40 minutes. And now let's focus on standard deviation. So standard deviation, I'm just going to write variance for everything because then we can easily calculate the standard deviation now. So variance of xc is going to be 36 minutes squared. Variance of xw is going to be, where is it, w, okay, 3 minutes squared. And variance of xt is going to be 25 minutes squared. 5 minutes squared. So variance of total, so total variance would just be addition of all of this. So we will get 36 plus 25. So 36, so that would be 36 plus 3 is going to be 39. I'm just going to add 1. So 40 plus 25 is going to be 40 plus 25 is going to be 65 minus 1, 64. So that is going to be our variance for the total time mean squared. So our standard deviation of t would just be 60 square root of 64, which would be 8 minutes. So our total time, so e of t equals to 40 minutes, and standard deviation of t is going to be 8 minutes, sorry. Alright, so that's how we do this, I think, and let's move on. So Josie's waiting time for a train on each workday is independent of her waiting time for a train on any other workday. The probability for 12 randomly chosen workdays, Josie's average time is between 7 minutes 45 seconds and 8 minutes 30 seconds is equivalent to this, and a and b are real numbers. So we have to find the values of a and b. So we know that z equals to x minus mu on standard deviation. Our lower bound for, so finding the value of a, basically z lower is going to be, so what's our x? We can't say 7.45, so 45 on 60 would give us 3 on 4, so that would be 7.75 minus the mean of waiting time. So what is the mean of waiting time? 8 minutes on standard deviation of waiting time, which would be square root of 3. Okay, square root of 3, so that would give us negative 0.25 on square root of 3, and our upper bound, not lower, upper bound would be 8.5 because 8.5 minutes, so 8.5 minus 8 on square root of 3, which would give us 0.5 on square root of 3. So our a is going to be negative 0.25 on square root of 3, and b is going to be 0.5 on square root of 3. Okay. Moving on to question number 7. So this is saying that a curve is defined by parametric equations of this and that, okay, and is rotated about x-axis to form a hollow surface of revolution. Find the surface area of revolution. Okay, surface area, not volume. Okay. So first we need to differentiate this in terms of x and t and y and t so that we can use the volume of surface area that is given in the formula sheet. So this would just become t on 2, and dy dt will become just square root of 3. So now we can just simply apply the formula, which is just going to, I'm just going to use that from the formula sheet. So 2 pi 0 to 2, that's correct, square root of 3t times the whole thing, so t squared on 4. So we're just squaring that and then plus, not 3, so that, okay. So I'm going to now bring the root 3 out, so we will get 2 pi root 3, 0 to 2, and then the whole thing again, so t times t squared on 4 plus 3, and we'll then get 2 pi root 3 times 0 to 2 t times t squared plus 12 on 4 dt. I forgot to write dt. Okay, and I'm going to now take the 4 out, so 2 pi square root of 3 0 to t on 2 times t squared plus 12 dt. Alright, and we will get pi square root of 3 0 to 2 t times t squared plus 12 dt. Okay, I am going to say that let u equals to t squared plus 12, so du dt would be 2t. So dt equals to du on 2t. So substituting that back, but before I do that I need to rearrange the coordinates as well. So not coordinates but the terminals. So new terminals would be equal to, so first one would be u equals to 12 and the other one would be 16. Alright, so pi square root of 3, so first one was 12, the other one was 16, and then so dt equals to, so this would just become t times square root of u du on 2t, so t and t cancel out, so this would just become square root of u on 2 du, and I'm going to bring the 2 out as well, so pi root 3 on 2 12 to 16 d root root u du, and now let's integrate, so pi root 3 on 2, and this would be 2 over 3 times u to the power of 3 on 2, 12 and 16, so pi root 3 on 2, 2 on 3 times 16, and now this is going to be to the power of half times 3, so minus 2 on 3 times, again 12 to the power of half to the power of 3. Okay, so simplifying that, we will get 2 on 3 times, okay, so 4 to the power of 3 would be 64 minus 12, then we will get so 4, so 12, this would just get 4, so 4 times 3, so 2 root 3 to the power of 3, so we'll get 8 times 3 times root 3, so 24 root 3, so 2 on 3 times 24 root 3, so that would cancel out, and okay, this is so much algebra. Okay, so I'm going to okay, so this would be 128 on 3 minus 16 root 3, and simplifying that, we will get pi root 3. So I'm going to cancel out this 2 with these, so 64 minus 8 root 3 on 3. Okay, so this should be our answer. Now there are high chances I made an error somewhere, so just let me know in the comment if I did, because this was a really hard question. Not hard, but not like conceptually hard, but just algebraically very hard. There we go. Okay, so now we have an induction question, and this doesn't look fun at all. So, a function has a rule of this. Use mathematical induction to prove that f to the power of n x is going to be this for n is all positive integer, where that represents the nth derivative of f of x, that is, f of x has been differentiated n times. Right, okay, so prove that n is equals to 1 is going to be true. So that's our first step for induction. So f of x, I'm going to just use the normal way of differentiating it, so it will equals to e to the power of 2x. So that will be 2x e to the power of 2x plus e to the power of 2x. Right, which would be e to the power of 2x, 2x plus 1. Okay, now I'm going to use the formula, so using formula. Okay, so then we will get f of 1x, which is equals to 2 to the power of 1x times x plus 1 times 2 to the power of 0, or all of that times by 2 to the power of 2x. So we'll get 2x plus 1 times e to the power of 2x. Therefore, we can say this is true for n equals to 1. Okay, now the second step is assume that n equals to k is going to be true. Something like that. So f of k of x is going to be according to the formula, which is 2 to the power of kx plus k 2 to the power of k minus 1, all of it times e to the power of 2x. Right, so that is, assume that it is going to be true, and now we have to prove that n equals to k plus 1 is also going to be true. So we have to prove that, and that will be the end of our induction basically. So what I'm going to do is I'm going to first apply the formula, so k plus 1 of x, that would be equal to, what is the formula again? Actually, maybe I can just get it from here to 2k plus 1 x plus k plus 1 2 to the power of k plus 1 minus 1, so just 2 to the power of k plus 1 minus 1, so just k, all of that times e to the power of 2x. So this is differentiated by using formula. So now what I'm going to do is I'm going to differentiate this again, because because theoretically, if this was to be true, if I differentiated this one more time, I should be able to get this right. So using that logic, I'm just going to differentiate that now. So f k x equals, so I'm going to just write this again, k 2 to the power of k minus 1, all of it times e to the power of 2x. So let u equals to 2 to the power of kx plus k times 2 to the power of k minus 1, and v equals to e to the power of 2x. So that would mean that du dx would simply just be 2 to the power of k, because all of this is just 0, and dv dx is going to be 2e to the power of 2x. So now we can say that f of k plus 1 x is going to be u dv dx plus v du dx. So just applying the product rule over here, so we'll get 2kx plus k 2 to the power of k minus 1 dv dx, which is going to be times 2e to the power of 2x plus e to the power of 2x, which is v, and times it by differentiation of u, so which is just 2 to the power of k. Okay, now what I'm gonna do is take out e to the power of 2x as common factor, so equals to 2 e to the power of 2x, so 2kx plus k, 2 to the power of k minus 1. Oh, hold on, I'm forgetting a 2, so that would become 2 times 2kx plus k, 2k to the power of k minus 1 and plus 2k, if I'm not wrong. Let me just double check. That looked promising. Okay, so if I were to further continue my calculations, I will get e to the power of 2x. Now we can treat this as 2 to the power of 1, so using that we can say 2 to the power of k plus 1x plus k 2 to the power of k, because this is to the power of 1, so addition would just become k, plus 2 to the power of k. So now I'm going to take out 2 to the power of k as common factor here, which would be e to the power of 2x, 2k plus 1x plus 2 to the power of k, k plus 1. Okay, now is this going to match the correct option? Yes, it is. So as you can see, this and this are the same, so hence we can say that hence proved by induction. Hence proved by induction. Okay, this question. Wow, a lot of algebra here. Whew, okay. A plane contains point A, B, C, where A is a real constant, okay. The plane has a y-axis intercept of 2 at point D, so what is going to be a point D? So that would just be 0, 2, and 0, pretty self-explanatory here. And AB, so now we have to find the vector AB, it seems like. Okay, we have to show that AB is this and that. Okay, so that would just be B minus A, so negative 1, minus 2, 4, minus 1, and then 3, and minus 2, which we will get minus 2i minus 5j plus 6k. So there you go, that's done. And AD would be D minus A, so that would be 0, 2, 0, minus 1, 3, minus 2. So we will get minus I minus j and plus 2k. So there you go, that is shown. Hence find the equation of the plane. Okay, so n equals to AB cross, so we just use cross product here, so that would just mean that ijk and AB is going to be negative 2 minus 5 6 minus 1 minus 1 2. Okay, so we'll get I and then negative 5 2 minus 1 negative 5 6 not 2 6 2 minus j, which is going to be minus 2 6 negative 1 2 plus k, which is going to be minus 2 minus 5 minus 1 minus 1. Okay, so we will get so minus 5 times 2 is 10, plus 6 is going to be minus 4, so minus 4i, so minus 4i minus, now minus 2 times 2 is minus 4, plus 6 is going to be, okay, hold on, minus 2 times 2 is going to be 4, plus 6, so 2 plus, so minus 2j, plus minus 2 times minus 1 is 2, minus 5. 2 minus 5 is going to be minus 3, so minus 3k. So our equation of the plane will be minus 4x minus 2y minus 3z equals to something, let's say d, and I'm just going to substitute. So at 0 to 0, what is our d? So our d is just going to be 4, so implying that d equals to 4. Therefore, equation of the plane will be 4x minus 2y minus 3z equals to minus 4, not 4, minus 4. There we go. Okay, so hence find the value of a. So now it's just a matter of substituting in the coordinates. So a minus 4a, and then was it minus 1, I think? Yeah, minus 1, so plus 2, and then minus 15. Just making sure, yep, equals to minus 4, so minus 4a minus 13 equals to minus 4. So minus 4a equals to 9. So therefore, a is going to be minus 9 on 4. Alright, so AB and AD are adjacent side of parallelogram. Find the area of this parallelogram. So in that case, we just have to find this cross product of this and that, and we just have to find the magnitude of that. So we already have the cross product. So that would be 16 plus 4 plus 9. So we'll get square root of 29. So that should be the answer. Okay, moving on to question 10. Wow, this is a long exam. 10 questions. Anyway, the position vector of a particle at t second given by this. So this is our position vector where t is greater than 0. Important. Write 5 minus 6 sine squared t in the form of this, where a and b are positive integer. Okay, so we know that sine squared of t equals to half of 1 minus cosine of 2t. Right, which looks similar to this form, so we can just use that. So 5 minus 6 of half times 1 minus cosine of 2t. So we will get 5 minus 3 of 1 minus cosine of 2t, meaning that 5 minus 3 plus 3 cosine of 2t. So 2 plus 3 cosine of 2t. And that's going to be our answer. So alpha equals to 2 and beta equals to 3. Okay, show that the Cartesian equation of the path of particle is going to be this. Okay, so we know that x is going to be 2 plus 3 cosine of 2t, as we already derived before, and which would mean that x minus 2 equals to 3 cosine of 2t. And let's do the same for the y. So y equals to, what is it, y? 1 plus, okay, so this is another identity. So we can say 6 sine t cos t is going to be 3 sine of 2t. So y minus 1 equals to 3 sine of 2t. Okay, so now we can say x minus 2 whole squared plus y minus 1 whole squared equals to 3 squared cosine of squared and plus 3 squared sine squared of 2t. So then we'll get x minus 2 whole squared plus y minus 1 whole squared, which is equals to 9, because this would end up being 1, and yeah, okay. There you go, so that's proven. Okay. A particle is at point A when t equals to 0 and at point B when t equals to A, where A is a positive real constant. If distance traveled along the curve from point A to point B is 3 pi on 4, find the value of A. So, okay, so we just have to use the arc length formula over here. So dx dt. First, we have to differentiate, of course, for the arc length, and we will get what we'll get. Oh, we just look at this. That will be easier. So minus 6 sine 2t. So minus 6 sine of 2t, and dy dt. We will get, what will we get for dy dt? It will be 6 cos 2t. So 6 cos of 2t. Yep, okay. So now we can just apply the formula. So arc length is just going to be 0 to a square root of dx dt whole squared plus dy dt whole squared. So it's 36 sine squared of 2t plus 36 cosine squared of 2t. Whole thing dt is going to be 3 pi on 4. So that would just end up becoming mod of 6 dt. I've just skipped a couple of steps because sine squared and cos squared just become 1. So 36 times 1 is going to be 36. Square root of that is going to be modulus of 6. So since t is greater than 0, we can say that 0 to a is going to be 6 dt, which means that 6t 0 to a is going to be equals to 3 pi on 4. So 6a equals to 3 pi on 4, meaning that a equals to 3 pi on 24, so 3 pi on 8. Okay, there we go. So that's going to be our a. Alright, and find all the values for t for which the position vector of particle rt is perpendicular to its velocity vector. Okay, so that just means that dot product between these two vectors should be 0. So we already have a velocity vector, which we already found here. So dx, dt, and dy, dt, yeah, they are basically our velocity vectors. So minus 6 sine of 2t I plus 6 cosine of 2t j is going to be a velocity vector, and rt again is going to be what? So 2 plus 3 cosine of 2t, 2 plus 3 cosine of 2t, I plus, what's the y value? 1 plus 3, 1 plus 3 sine of 2t j. Okay, so rt dot product velocity vector, it has to be 0 for this to be true. So minus 6 sine 2t times 2 is going to be minus 12 sine 2t, and minus, so this times that, which would be minus 18 sine of 2t cosine of 2t plus 6 cosine, so this times 1, so 6 cosine of 2t, and then now this times that, so plus 18 cosine of 2t sine of 2t has to be equal to 0. So this and this will just cancel out, leaving us with 12 sine of 2t plus 6 cosine of 2t equals to 0. So I'm going to divide the whole equation by 6, so minus 2 sine of 2t plus cosine of 2t equals to 0. So that would mean that 2 sine of 2t equals to cosine of 2t, and let us divide, making this a tangent. So 2 tangent of 2t equals to 1, so tangent to t equals to half, so that would mean that 2t equals to tan inverse of 1 on 2, so t equals to tan inverse of half divided by 2. Now, do we have any domain? So t is just greater than 0. Okay, so I don't think we have any specific domain over here. So what I'm gonna say is I'm just going to write a general solution. So t equals to tan inverse of a half on 2 plus pi n on 2, because that would be the period of, yeah, tangent of 2t, where n is going to include all positive integers including 0. Okay, that should be the answer, and okay, that's it. Good. So this is the 2023 exam 1 for specialist done and dusted. Hope you found it useful, and thank you for watching.